So now let's continue this discussion and look at the current that's flowing. Now keep in mind this is a series circuit, so IC of T, you might think of it as being over here, but we got to remember that this is a series circuit and the current flow, we might call it IS for I source, is equal to the current flow in the capacitor, okay, at this instant in time, okay. The other thing we're doing is we're looking at this at time equal to 0. And recall, if we take a look over here at t equal to 0, if we look at our series circuit, remember the capacitor was a short circuit, right? So what happens is, another topic I need to introduce right here is that the current can change instantaneously in a capacitive circuit, or in a capacitor. The voltage cannot. When we get to studying inductors, we'll find that the voltage can change on an inductor instantaneously, but the current cannot, okay? So what happens is, right at t equal to 0, if we could just stop time at that point in time and investigate a little bit, the capacitor looks like a short circuit, and we have a real simple series circuit at that moment in time where we've got 20 volts across 8K ohms, and what happens is the current, now if I put this on a timeline, T, and I use every 2 block for tau, 5, 6, okay, the current instantaneously at time equal to 0 goes to 2.5 milliamps and begins to decay from right there. If you haven't ever studied this before, we'll find that this negative t over something is what we call a decay function. A little tidbit of information to know. So right at t equal to 0, that current spikes right up to 2.5 milliamps. All right? And now, again, if we do this a little bit quicker, and just say that this is 1 tau, 2 tau, oops, not 2 pi, 2 tau, 3 tau, 4 tau, and 5 tau. And remember, anything beyond that is what we call steady state. Okay? So let's take a look at t equal to IC of 1 tau. That'd be 2.5 milliamps times e to the negative tau over tau. And we end up with 2.5 milliamps e to the negative 1. And that turns out to be 0.9197 amps, or I'm sorry, that is milliamps. Okay, so it should be 0.9197 milliamps. Then we can go ahead and calculate 2 tau, 3 tau, 4 tau, and 5 tau. Okay, so if we do those calculations, this is what we get there. We ramp up to 2.5 milliamps, and then at 1 tau we get down to 0.9, which is right in there, I guess, and then a third of that, which is there at 2 tau, and then we're getting quickly down to 0.12. And we see that this guy now is heading to 0, so it spikes and then heads to 0. Okay, and that's the current. Now, the voltage across the resistor, again, just simply follows